Okay guys, so I set up our Diffusion Agar lab today. What I did was I made some agarose gel cubes here. I made them in different sizes. We have our 1 centimeter ones, our 2 centimeter cubes, and then lastly our 3 centimeter cubes. And each group will get 3 of each of the cubes. So before we start the lab, which I set up here for you, go ahead, write a hypothesis, read over the introduction to your lab, and come up with a hypothesis you think is correct. Give a little bit of a rationale on why you think that hypothesis will work. So make sure you do that. Now, what we're gonna do here, guys, is I'm gonna splice a bunch of videos together, but for our first video, I'm going to take our cubes right there, and I'm going to put them in our solution here that I made. And this solution is going to be sodium hydroxide. So this is a 0.1 molar solution of sodium hydroxide. So I'm gonna start off with the bigger, the 3 centimeter cubes, okay? And I'm going to put them in our solution. Why I'm doing it with the 3 centimeter ones first, guys, is just so they don't, if I put them in last, they're gonna crush the other ones. So put the biggest ones at the bottom. Okay. And if you notice, they are turning this pinkish color. What I did here, whenever I was making our agar cubes, is I put a base indicator in them. It's called phenolphthalein. So in the presence of a base, it turns this pinkish purple color. So what this tells us is that sodium hydroxide, NaOH, is a base. Okay, so they are in there. Now, if we look closely, you guys can notice that, let me pull one out here real quick. All right, they look pretty pink on the outside, all right? But if we look really closely, we can see that the inside of them, even this guy right here, he's a good one. But you can see on the inside, it's not as pink as the outside. The outside is all pink, and you can see it's slowly becoming more like translucent going in. In the middle is still not so translucent yet. So what we're gonna do is I'm gonna start a timer here, and we are going to let that soak for about 10 minutes in there, just so that the whole gel in all of our cubes, our 1 centimeter, our 2 centimeter, and our 3 centimeter, become completely translucent. And when they become translucent, what that tells us is that the sodium hydroxide has soaked through all the way to the middle of the cubes. All right, so we're gonna come back. I'll let this soak for about 10 minutes. I won't let you guys, I won't make you watch the video for 10 minutes, so we will be back. All right, guys, so we left it in there for about 10 minutes. I did a little bit extra just because the middle of our cubes were still a little bit cloudy. They weren't completely transparent. So they are now completely done. So what I'm gonna do, guys, I don't wanna get this stuff on my hands. So I'm going to use a spoon and I just got a dissection tray, and we're going to transfer them over. Let them dry for a minute or two. All right, so you guys can see we retained our pink purplish color here. All right, and they are completely translucent. We could see through them. I don't want to touch them, but we could completely see through them. So what I did now is I prepared 3 different beakers full of 1 molar hydrochloric acid. So phenolphthalein, this is going to be, whenever we have a base present, it's going to show that color, show that pink color. Whenever we put it in an acid over here, what's going to happen is that color is slowly going to leave because the acid is going to take away that base. We're going to pretty much neutralize it. So, to the best of my ability, we want to do these roughly at about the same time, which is not going to happen. So a little bit of experimental error on my part, but I'm going to drop these into the hydrochloric acid. Be nice if I had a lab partner here, but with the pandemic and everything, that kind of takes that out. Got to work alone. So in one beaker, I put all of my 3 centimeter cubes. In my second beaker, I put my 2s in. And in the last one, I'm going to put my 1 centimeter cube in. Okay. All right. So each one, you guys can see them there. We have our 1s, our 2s, and our big 3s here. So I'm going to start a timer here. We're going to give it about maybe 5 to 7 minutes. I'm going to observe them. And what's going to happen over time, you guys can see here for the 1s, you can see the outside is slowly starting to become clear while the inside is not. Same thing with the 2s. You can see the outside slightly clear around the edges of the cube. The insides are completely pink. And then our 3s, they're slightly clear on the outside, not too much. Okay? So we'll wait about 5 to 7 minutes, guys, and I will come back and show you what happened to them. Okay, so some time has passed. I gave it about 10.5 minutes, close to there, guys. Only reason I did that was so that we could see some pretty good results with respect to our diffusion. So we have our 1 centimeter cubes, our 2 centimeter cubes, and then we have our 3 centimeter cubes. So what I'm going to do is I'm going to pull them out. Again, please be careful, guys. This is hydrochloric acid, so you do not want to get it on your hands. So I'm going to use my trusty little spoon here. And once again, I'm going to put them on my dissection tray. I'm just going to let them dry for a minute or two. The only part about using the dissection tray that is a little less than advantageous to us is since the paper towel becomes translucent because the hydrochloric acid goes on there, it's a little bit more difficult to see the pink. So what I'm going to do is I'm going to let these dry for a minute, and then once they dry, I'm going to transfer them. I got a little old whiteboard here, and I'm going to transfer them to that. So whenever I transfer them, we should be able to see the pink a little bit better. All right, so I'm going to put them on here. Okay. All right, and you guys can see if you got the white background, you can see what part is pink a little bit better. So there is some hydrochloric acid, like I said, guys, still on our cubes. and they all have it on there. So we still can count this as, not being a variable because they all have hydrochloric acid on. If you notice the 1 centimeter ones, the pink got even a little bit smaller as we were transferring them over. And this is just because there's more hydrochloric acid seeping into the cubes. So next thing we're going to do, I'm going to get a little roller here, and we know already the volume of each cube. So I started a data table for you guys, a little different than the data table that we have in the lab write-up, but we had our 1 centimeter cube, our 2 centimeter cube, and our 3 centimeter cube. If we wanted to do the volume, this one would just be 1 times 1 times 1. We know that would be 1 centimeter cubed. This one would be 2 times 2 times 2, which would be 8 centimeters cubed. Last one, 3 times 3 times 3, and it would be 27 centimeters cubed. Okay, so next thing we're going to do, we're going to come over here. I'm going to start with the 3 one. All right, it doesn't matter which way you go first, guys. I'm going to do just this way first, and I get about 2.4 centimeters. So we'll do this as trial number 1. So we have 2.4 for our 1. So we did this one. Let's go this way next. That's about 2.2. And then our last one, we're going to have to flip it on its side, which I just did. And then our last one is going to be pretty much like the height, which is about 2.1. Okay. Next one. We got about 2.1 there. Okay. You guys can see how to do this. We're going to do length, width, and height for each one. All right, so I'm going to do measurements for these, and then I will come back and show you guys my data table nice and filled out. All right, so back to you guys. Finished filling out our data table here, but I also wanted to show you this. Like I said, there's still hydrochloric acid on and in penetrating the cubes, so they get, smaller. So you kind of got to do this quickly. Look at the ones. All that phenolphthalein is actually gone from the inside. So you guys can see that if you do it quickly, you'll get good results. If you lollygag and don't get your measurements quickly, well, some of your results might actually disappear. Okay? It's a base indicator. So more acid gets in there, less indicator you're going to be able to see as that base becomes neutralized. But here's what I did here. In green, I wrote our volume of each one. So I multiplied these together and I got our volume. Why I did the 3 trials, guys, is so that I have a good result. I have good data. All these numbers are fairly close together here, which is good. We want them close together. If we have one that's a big outlier, something went wrong. But they're all fairly close to one another. So what I did after this is I'm going to add our 3 trials up together, our 3 volumes, and then take an average of it. So add them up, divide by 3. For our 1 centimeter cube block, I get 0.041. That would be in centimeters cubed for our volume. The second one, add them up, divide by 3. I got 5.852, and again, centimeters cubed. And then the last one, I got 11.437 centimeters cubed as the lights go out. Okay, so here's your data table, guys. You can now transfer this information to your other data table in the lab write-up, and this will help you guys get started. And then you could see if you are going to accept or reject your hypothesis after you get your surface area to volume ratio. All right, guys, so that is the lab procedure. Hopefully this helped, and hopefully this data will be useful for you. Have a good one.